Consider the line. By definition, it is the depiction of a distance between 2 points, one of the most fundamental units of geometry. Yet simple lines, whether straight, curved, or meandering, grouped together in a purposeful pattern on the flat surface of paper, can convey from the hand of one to the mind's eye of another a three-dimensional world of infinite complexity and surpassing beauty, especially if the hand is guided by the genius mind of one such as Leonardo da Vinci. In the hand of Leonardo, sketched lines defined a keen understanding of proportion and gave visual form to power and grace. His lines on paper made the inscrutable understandable and endowed the mundane with an enduring enigma. He was a pioneer in his attitude toward machinery, believing that by understanding how each separate machine part worked, he could alter them and combine them in new ways to improve existing machines or create inventions no one had ever seen before. Today's industrial designers are heirs to Leonardo's unique vision. 500 years later, their process of creation still begins with a translation of an idea into lines on paper. And in their own way, successful designers who take advantage of the exceptional possibilities offered by PM are demonstrating a profound understanding of form and function, which yields solutions worthy of being considered part of Leonardo's legacy. Each year, MPIF sponsors an international competition aimed at discovering and recognizing the most outstanding examples of the industrial designer's art and the part producer's skill, applying PM's benefits to manufacturing structural components. Once again, as we do each year, we are now proud to showcase the achievements of those parts producers judged most worthy in this demanding competition. This year's winners in the International PM Design Competition clearly demonstrate the innovative tooling design, special properties, precision, reliability in demanding environments, performance, and cost-effectiveness that have become the hallmarks of PM. They perform in automobiles and light trucks, industrial pumps, power tools, and medical products, and are made by conventional press and sinter technology, warm compaction, and metal injection molding. Ladies and gentlemen, at this time we present to you the winning parts in the 2004 International PM Design Competition sponsored by MPIF, beginning with the Awards of Distinction. This output shaft hub, made by Chicago Powdered Metal Products Company for Ford Motor Company, has won an Award of Distinction in the Ferris category of the competition. The hub, which operates in a Ford torque shift truck transmission, was made using warm compaction to a minimum density of 7.2 grams per cubic centimeter and a minimum ultimate tensile strength of 155,000 psi. It is formed on a 1,650-ton compacting press utilizing 5 molding levels. The external helical teeth and straight involute splines are molded as a net shape and are particularly difficult to process via warm compaction. Using this process to produce the part, which had originally been designed as a forging, provided a 30% overall cost savings in a net shape part that surpasses the performance of a machined forging. Secondaries are limited to vibration deburring and some machining. FMS Corporation has won this year's other award of distinction in the Ferris category for a 101-tooth helical gear assembly, consisting of a ring gear, hub, and counterweight that drives a Graco-incorporated piston pump in a high-pressure industrial paint sprayer. A proprietary heating process is used to assemble the helical ring gear to the hub. The counterweight is mechanically fixed in the hub using a pseudo-swaging technique. The core holes in the flange and hub reduce material and allow the component to be balanced when assembled with a roller bearing. PM replaced a machined zinc die casting, providing an estimated 30% cost savings in the process. An award of distinction in the non-ferrous category has been won by this bronze gib used as a leveling device in a vertical machining center. Made by Pacific Sintered Metals, the PM part is made to a density range of 6.8 to 7.2 grams per cubic centimeter and has a minimum K strength of 37,000 psi. It offered a 60% cost savings over a machined component. Secondaries performed by Pacific Sinter Metals include oil impregnation and coining for dimensional control. An award of distinction in the injection molded category goes to World-Class Technologies for a Carrier distalizer made for Class 1 orthodontics. The distalizer provides a non-extraction method for starting complex Class 2 orthodontic cases and moving them into a simple Class 1 occlusal platform, which can be treated using any orthodontic technique. The complex part is made in two pieces, a posterior pad with a socket and an interior rod with a ball on one end and a pad with a hook on top at the other end. After sintering and polishing of the pieces, the ball is pressed into the socket in the posterior pad to make the final assembly, which comes in 3 sizes, each with a left and a right-hand version. Made from a nickel-free stainless steel, the parts are formed to a density of 7.6 grams per cubic centimeter. They exhibit a yield strength of 80,120 psi, an ultimate tensile strength of 95,520 psi, and a 22% elongation. Metal injection molding offered considerable cost savings and higher yield than competing manufacturing techniques such as investment casting. Another award of distinction in the injection molded category has been won by Kinetics Incorporated for a lower jaw used in a medical suturing device made by Opus Medical Incorporated. The lower jaw is a critical component of this medical device, which is used to place uniform stitches to a torn rotator cuff, designed to allow independent grasping and suturing with one hand. The high-precision complex shape is made from a 17.4 pH stainless steel to a density of 7.7 grams per cubic centimeter, a typical tensile strength of 130,000 psi, and a typical yield strength of 106,000 psi. Minor secondary operations include reaming 3 holes, coining, and sizing. Sinterstahl Pomatasa in Spain has won this year's award of distinction in the overseas category for an external proportional valve used in a new electronic automotive shock absorber. Made to a density of 6.7 grams per cubic centimeter, the complex copper steel PM part has an ultimate tensile strength of 49,000 psi and a transverse rupture strength of 93,000 psi. Ladies and gentlemen, these are the winners of the Awards of Distinction in the 2004 International PM Design Competition. Please join with us in saluting them as we invite representatives of the winning companies to come up and accept their awards.